Hello and welcome to the next subunit lesson. So this subunit is going to be air masses and fronts. We're just going to be talking about different air masses, different fronts, and how they affect the weather and climate around us. Okay, so the objectives for this unit are going to be, subunit, excuse me, are going to be learning the four kinds of air masses, the four kinds of fronts. We're going to learn about fronts and how they affect the weather, and then we're going to learn about cyclones and anticyclones. So that's all we're going to need to know for the quiz and later on the final exam. Okay, so the four kinds of air masses we have are, they're split up into two, cold and warm. So with cold air masses, we have continental polar, and so that's classified with a little c, big P. And essentially what that is cold. It's a cold air mass that is over the continent. And then we have maritime polar, which maritime is marine, which we will correlate to the ocean. So maritime polar is going to be a cold air mass that is over the ocean, either the Pacific or the Atlantic. Then we have warm air masses. We have continental tropical, little c, big T. That's going to be a hot air mass over the continent. A lot of the times you find those over deserts. And then we have maritime tropical, and that's little m, big T. So that's going to be in the oceans, the Pacific or the Atlantic, and it's going to be warm tropical weather being flowed in from there. So here's a nice little graphic of all of the different air masses. So if you want to look into this with more depth later from the PowerPoint, you can get a lot of, these are going to be like answers for quizzes, so like what kind of air is tropical or continental tropical? It's hot, dry air. So the thing to know about these things is kind of just like the distribution. So right here we have the jet streams, right here and right here. And these are cold jet streams. You can tell because of the blue little spikes here. They look like icicles. That's a really easy way to tell that it's a cold front if it has those icicles. And so these jet streams are always cold. So we're going to get into the continental tropical here. So the continental tropical in this certain section of the Earth is a very small front or a small mass, air mass. But what it's going to do is it's going to be hot, it's going to be dry air. It's going to push up here until it hits this cold front, and then it's going to kind of go up and dissipate into the atmosphere. And so then we got right here in the Atlantic Ocean, maritime tropical. This is going to be like a lot of this air mass is going to be where hurricanes come from. You can see right here, this area just got devastated by the multiple hurricanes that ripped through this whole area about a month and a half ago. And then we've got maritime tropical over here on the Pacific, which is going to bring warm, moist air over into here. El Nino is kind of like intuitive with maritime tropical air masses. El Nino is just like a period of more warm, moist air coming into this sort of area up in here. Even all the way up into Alaska, we had an El Nino event that was strong, the strongest El Nino in the past 2,000 years, these past 4 or 5 years. And so then we've got maritime polar. And you can see up here we're like up in the polar regions. So it's over the ocean, it's in a polar region, so it's maritime polar. And what you're going to want to know about that is that it's going to be moist, cold air. So you're going to get a lot of snowfall in these areas over here. And then we've got continental polar. It's in a polar area. It's over the continent, so that's what makes it continental polar. And right here, it shows you that it's going to be cold, dry air. So up in here, this is tundra. It's really dry in the tundra. It's technically a desert because there's not a lot of precipitation being moved around in there. That's just a fun fact. You don't need to know that. But go ahead and take a look at this PowerPoint on your own. Okay, and then here's just like a really big map of all the different types of air masses. So we've got Arctic, continental Arctic, which you don't need to know. You need to know continental polar, marine polar. Those are in those two oceans here. Marine tropical in those two oceans again, and then continental tropical. Why I showed you this is because think about where all the deserts are in the world. Right here, right here, and right here. It's all continental tropical, okay? And then we also have up here is a desert, even though it's tundra, and up here is a desert, even though it's tundra. And that's continental polar. So a lot of the times with continental air, it's going to be dry air. The moist air is going to come from the maritime cold fronts, or not cold fronts, sorry, air masses. Okay, so here's just another really good PowerPoint explaining the types of weather that these air masses give you and where they form. So this is a really, really, really good slide for the quizzes and the post-test. So go ahead and use these. I do not care if you use them. Okay, so let's get into fronts. So we have four kinds of fronts, and those are just like weather events due to air masses. So a cold front is going to move very quickly. Cold air is denser, so it's going to move under the warm air. It's going to create precipitation, like normally heavy precipitation. With cold fronts, you get a lot of storms. So you're going to get thunderstorms, snow, heavy rain, and afterwards cooler temperatures. We get warm fronts, which are less dense. Warmer air is less dense than colder air, so it's going to move over the colder air. When it mixes with that cold, dense air, you get drizzly rain. But once it dissipates, you end with a clear, warm, normally sunny weather. So then we're going to talk about occluded fronts. And occluded fronts are when warm air is caught between two cold air masses. So it's like a rock between a rock and a hard place. So look at my head. We've got a cold air mass. My head is a hot air mass. And then we've got a very cold air mass. And so my head is just stuck between those air masses. What we see with occluded fronts are large amounts of precipitation, typically rain and snow, and then afterwards you get cool temperatures. Not as cold as cold fronts, but it's still cool. And then the last kind of front is a stationary front. And so when you think of stationary, you think of immobile, it's not moving. So what's happening there is cold air is meeting warm air, and they're kind of doing this action, but there's not enough energy or force to move the two masses over each other. So what happens is they just remain separated like this. And so what's going to happen with this stationary front is you're going to get many days of cloudy, wet weather. So a lot of stationary fronts in like London and Ireland. I think Seattle is a good example of that, but I'm not 100% sure. So here's just like good descriptions of all the fronts. So we've got a cold front here. We've got that warm air mass that, we know that warm air mass is less dense. So this cold air mass comes in, it pushes that warm air mass up, it moves the cold air down, and the front starts to move to the right. And so we get a lot of mixing. And so when you get a lot of mixing and heat mixing, there's a lot of energy in the system. So that's when you get storms, is when a lot of energy gets mixed in a system. So then we've got a warm air front. The warm air is moving to the right. Since it's less dense than the cold air, it's just going to continue to go up and above the cold air. If it mixes, it's going to have like a little bit of a drizzle, but other than that, you're going to get nice, warm, sunny weather all throughout here. Here's an occluded front, just example of that warm air between two cold air masses right here. So when they mix, you're going to get that, like I said, warm air mixing, a lot of energy in the system with heat. You're going to get those storms again. Not as much as a cold front though, because it doesn't mix quite as much as a cold front, because the cold stays down here. Whereas this one, it's going to make a convection current. And then here, the last one is a stationary front. You have this warm air mass right here meeting up with the cold air mass, and nothing's really happening. You're going to get some drizzle, some rain here, and then clouds right in here with more rain. Okay, and so here is just another really good PowerPoint for the quiz. I urge you to look at this PowerPoint a lot before you take the quiz. Just kind of get the concepts down, and make sure this PowerPoint is up when you're taking the quiz, because all the information you need is right here. So I'm not going to go over it too much for you. And then here is just one more really, really good example of a good PowerPoint to have open for the quiz. One thing that I want you to look at is when you're looking at like the weather report, when you see this little line with these icicles like I was telling you about, that's indicative of a cold front, those icicles. Just remember that. And then I like to think of these as suns for warm fronts. And so when you think of the sun, you think of hot. And so just think of these red circles as the sun. So that's how you can distinguish that between a cold front and a warm front. And then stationary, it makes sense. There's a warm front mixing with a cold front. They're not quite mixing together like this occluded front. So they're just kind of staying in one spot. So it's not super important you know these, but it's just interesting. You'll be able to look at what the weatherman's showing you and know what he's talking about. So let's get into cyclones and anticyclones. So the thing you really need to know for the quiz is that a cyclone is an area of low pressure. It's a low pressure area, okay? And that usually causes a system of instability. So what's happening is air is rising, it's creating a convection current, and it's causing violent stormy weather because all of that energy is just kind of being mixed counterclockwise in the northern hemisphere. And that's kind of like hurricanes are a really good example of a cyclone. They move counterclockwise. It's a low pressure system in the eye. We know that the eye is a really low pressure system. Air is rising. It's creating this very large convection current, and then it's causing this violent stormy weather. The interesting thing about hurricanes is that once they hit land, they lose a lot of their energy. They get most of their energy from the heat in the water. So that correlates with global warming. If we have a rise in temperatures in the water, we're going to have more energy in the system for hurricanes to take. So we're going to have more severe weather patterns. And so then we'll go to anticyclone, and that's just the complete opposite of a cyclone. It's an area of high pressure. So what's happening is it's pushing down, and then that air is getting pushed down and it's dissipating out. So we're getting these nice sunny days because clear, dry weather is what they say. But you're getting nice days because there's not as much energy in one area of the system. So it's coming like this and it's dissipating out. Whereas with the cyclone, it's going like this and it's circling around itself. So it's creating this crazy turbulent energy system. Okay, and here is just another good diagram of what I'm trying to tell you here. So a cyclone, we get this low pressure. It creates a convergent convection current in the system. So that hot air is rising. It's kind of condensing in this area right here, and it's spinning counterclockwise all the way up. And eventually it's going to get dense and it's going to be able to precipitate. So that's when you see a lot of rain. And then an anticyclone is the complete opposite. There's a lot of pressure, so the air is getting pushed downwards, and then it's getting diverted. So when you think of things getting diverted, like water getting diverted, there's a lot less pressure in the system when it gets diverted. So we get this high pressure system pushing the air down and pushing the energy out. This is a low pressure system. It's pushing the air up and pushing the energy up and making it rotate in a counterclockwise way. And so then we'll just look at this little diagram right here. Low pressure system, it's going to push the energy up, create a convection current counterclockwise in the northern hemisphere due to the Coriolis effect. You don't really need to know that, but it's interesting. And you get this cyclonic flow. So think about hurricanes. And then right here we've got a high pressure system. It's going to push the air down, down, down clockwise, and then it's going to dissipate. And so a lot of the times with hurricanes, you get this counterclockwise, low pressure system pushing all this energy up and up and up, and then it gets dense, and it actually, when hurricanes stop and they dissipate, they actually hit the continent, and they get into an anticyclonic flow. So it goes up and around and around and around, and then it gets pushed over because this is continuously pushing up, and so it gets pushed over, and then it goes into this clockwise pattern. And it goes down because there's a lot of pressure in that system. It goes down and then dissipates. And so that's when you see the end of hurricanes, that's what's happening, is we're getting this cyclonic flow that's eventually turning into an anticyclonic flow and dissipating. So that's all you're going to need to know for this quiz and unit post-test. Make sure you take a look at the PowerPoints again because I went pretty quickly over it. And make sure you let me know if you have any questions, comments, concerns, because I am here to help. Okay, so we'll see you on the next one, and have a great week.